Hello everyone, welcome to our series of DepthInsight teaching videos. This video will introduce how to build a structural model. The main steps are listed below. Import data, make faults, make horizons, make zones, model editing and checking. Double left-click on the DepthInsight icon to open the software main interface. Select Modeling to open the 3D modeling software. First, make a brief introduction about the software interface. Menu bar is on the top. Toolbar is in the second line. It mainly includes the shortcut buttons for each module. The default one is Structural Modeling module, and we can switch to other modules by clicking the corresponding shortcut buttons. The last few buttons are view control buttons, and the most often used button is Combination. Left-click Combination to activate it. Hold the left button and move the mouse. Can rotate the wheel. Press Ctrl and at the same time hold the left mouse button and move the mouse. Can pan the wheel. Scrolling the mouse wheel can realize the function of zooming. So the combination button can realize the function of rotate, pan, and zoom. It is very necessary to master this tool in order to use DepthInsight efficiently. Pan, rotate, zoom button have the corresponding function respectively. View All button, Projection Wheel button. It can realize the corresponding functions. The tree pane is in the left side. The corresponding property can be set in the right side Properties pane. Model result will be shown in the central part, the 3D display window. The information pane is on the bottom to provide the working information and prompt message. Before building the model, we need to import the seismic data. First, import fault segment data. Select a corresponding file type based on the data format. We can preview the data format in the right window. We can see the space range of the fault data. If the z-values are negative, just press OK to proceed. Otherwise, check the negative z-value box. For this case, just click OK. Press Yes to extract the survey. Then the fault data will be imported and showed in the display window. Next, import the horizon data. Choose a corresponding file type. We can see the space range of the horizon data. If the z-values are negative, just click Set for All to proceed. Otherwise, click the negative z-value box. For this case, just click Set for All. Press Yes to extract the survey. Then the horizon data will be imported and showed in the display window. Save the model. The horizon surface cannot be generated before saving the model. The default domain is time. If imported data comes from depth domain, then switch it in the Properties pane. For this model, we are using the time domain data, so just keep the default one. Set the grid parameters. The default grid size is 200. You can reset them according to the survey area. For this model, just keep the default value. You can change the background according to your preference. Uncheck the false node. Sort the horizons by z-values and check whether the horizons nodes are sorted based on the deposition sequence. Draw the model boundary. Right-click Structure Model. Select New to start the boundary drawing function. Left-click to start. Draw a closed polygon along the stratum points. Double right-click to end. You can choose whether to display the model boundary in the Properties pane. Close the horizons and open the faults. There are 3 calculation methods of the fault boundaries. Sculpted border is the default one, and we recommend to use the convex hull border in this model. Then update the fault surface. Close the faults and show the horizon data. There are 4 horizon generation algorithms, and we choose the default one, minimum curvature. Then generate the horizon surface. Then make zones. So after the 3 steps, make faults, make horizons, and make zones, we have completed the establishment of the initial model. However, this initial model is without any editing and may have abnormalities at some local areas. So we need to inspect and edit the faults and horizons. And after detailed inspecting and editing, we can regenerate the faults and horizons and make zones again. That is to say, the small workflow is make faults, make horizons, and make zones. And the entire workflow of building a reasonable structure model is just a process of cyclical iteration of many small workflows. Next, I will give a few examples to show how to edit faults and horizons. Close the horizons and open the faults. We can see there exist lots of faults in the display window. and it is very easy and quick for us to find a specific fault. Left-click the fault node, then move our mouse to the display window. Left-click the targeted fault, then the corresponding fault node will be automatically selected. Right-click this node and select Hide All Accepted. We can see the fault surface is not smooth. There are some local abnormalities which are caused by the abnormal segments. We can solve this problem by editing these segments. Right-click Segments, select Edit. Delete the unreasonable segment or point. Then update the fault surface. We can see the fault surface becomes smooth. Likewise, we can edit other faults in the same way. Next, I will define the truncation relationship between faults. First, display all the faults, and find two faults have this relationship. The fault's name appears along the mouse movement. We can see there is an obvious truncation relationship between the green fault and the yellow fault. Only show these two faults for a better observation. We can see the green fault was truncated by the yellow fault. That is to say, the yellow fault was the major fault of the green one. Edit the boundary of the green fault to make it fully intersected with the yellow fault. Choose Assign Major Fault of the green fault. Double left-click on the yellow fault. Then update the green fault. Now the truncation relationship was defined. Next, I will define the truncation relationship of another two faults in the same way. We can see the green fault was truncated by the orange fault. Adjust the boundary of the green fault. Assign its major fault. Then regenerate the fault surface. This is a few examples of how to edit the faults. Next, I will give a few examples of how to edit the horizons. Close the faults and open the horizons. Because the faults have been changed just now, so we need to update the horizon surfaces first. Then check the horizons one by one. Take horizon H6 as an example. Check the quality of this horizon surface. Here we found an horizon generation issue. The surface doesn't match very well with the original data. Pick up this fault and show it. This is a reverse fault. However, it shows normal fault displacement in this local area. We try to reset the parameter of clean distance to solve this problem. Discrete points within the clean distance of a fault are regarded as error points and will not be used when generating horizons. Set this value smaller, then regenerate the horizon surface. Now we can see the horizon surface around the fault becomes reasonable. We can also set some nearby discrete points as control points to solve this problem, because control points are not affected by clean distance of a fault. First, replicate the former problem. Then cut the nearby discrete points and paste them to the control points. Then regenerate the horizon surface. We can see this problem has also been resolved. Now open H3 horizon and examine its quality. This local problem was because we didn't define the truncation relationship of these two faults. Pick up these two faults on the surface. As we can see, the orange fault was truncated by the yellow fault. First, adjust the boundary of the orange fault to make it fully intersected with the yellow fault. Assign major fault. Double left-click on the yellow one. Then update the fault surface. Regenerate the horizon surface to see the effect. After detailed inspecting and editing all the faults and horizons, regenerate all the horizons again. Make zones. Hide the discrete points. Hide the surfaces. Use gradient color to show the zones. Create sections to check the model result. Rescale Z direction for a better observation. We can also create closed sections to check the internal structure of the model. If there are unreasonable abnormalities, then we need to edit the corresponding fault or horizon and regenerate the model again. This is the main workflow of building a structural model. If you have any questions, please refer to the corresponding teaching videos. Thanks for watching, and here is our contact information. Please contact us if you have any problem. Thank you.